All right. Hey, everyone, ready to dive in? Today, we're going to get into geospatial analysis with Python.
Yeah, should be fun.
Now, you might be thinking, okay, wait, is this, like, for me?
Right.
I get it. Maybe you're just starting out in GIS.
Yeah, could be.
Or maybe you're a manager and you're hearing Python, 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 but need a, clearer path to see what all the hype's about.
For sure, and that's exactly why we're doing this deep dive.
Yeah, that's why we're here. We're going to break this whole thing down. Start with Learning Geospatial Analysis with Python.
4th edition.
By Joel Lawhead. This book, it really hooked me because it doesn't just throw a bunch of theory at you.
Mm-hmm.
It focuses on practical techniques, stuff you can actually use.
Absolutely. And to that point, Joel Lawhead, he is a great guide for this.
Yeah.
And I think you'll agree, he's not just an author. This guy's been really deeply involved in the geospatial world for years.
Oh, yeah.
He is a certified project management professional.
Okay, so the guy knows how to get things done.
GIS professional, and even vice president of an award-winning geospatial firm.
So, okay, serious credentials.
Yeah.
But here's what I find really cool. He's been combining Python with geospatial work since 2000.
That's right.
Way before it was the trendy tech darling.
Exactly. Long before it was cool. And he wrote the QGIS Python programming cookbook, so he really knows his stuff.
Okay, wow. So that's he was ahead of the curve.
Yeah.
So before we get into the nuts and bolts of Python and everything, let's do a step back. I think for me, I always struggled to kind of fully grasp what geospatial analysis actually is.
Okay.
Can you help me out?
Of course. So really, at its core, geospatial analysis is all about analyzing data that's tied to locations on Earth. It's really understanding the where, along with the what.
I see. So it's not just making pretty maps.
Well, maps are definitely a part of it.
Yeah, okay.
But it's much more than that. It's about finding patterns, relationships, and insights that are hidden within that geographic context of the data.
I always thought that this was a pretty modern field, but the book mentioned some really old examples of geospatial thinking, even cave paintings.
Exactly. The book starts off with a fascinating look at the historical roots. So think about those ancient cave paintings where hunters would mark the location of prey alongside lunar cycles.
Okay, yeah, and they show that in Figure 1.2, right?
Yes.
Wow, so they were basically predicting the movement of animals based on location and time.
Right.
That's pretty impressive for, cave dwellers.
Absolutely. And it really just shows that humans have been thinking spatially for a very long time. Mm-hmm. And then, as our tools and technologies have evolved, so too have our capabilities.
Right.
Another great example is from the 1800s when Europe was grappling with cholera outbreaks.
Yeah. Oh, I remember learning about Dr. John Snow, that famous cholera map in London.
Yes, exactly. Yeah. And he pinpointed a contaminated water pump as the source of the outbreak by mapping the clusters of cases. Mm-hmm. And you can see that in Figure 1.3. And, it's just a classic example of how geospatial analysis can be used to solve, real-world problems.
Yeah, that's a powerful example. It's it shows how mapping can be a literal lifesaver.
Absolutely, it can. The book also mentions Charles Menard's incredible infographic mapping Napoleon's disastrous Russian campaign in 1812.
Oh, yeah.
It's this stunning visual representation of how troop movements and temperature changes, geography, all played a role in the outcome of that campaign.
Wow. Those historical examples.
Yeah.
They really put things into perspective.
Yeah.
It's amazing to see how geospatial analysis has been woven into the fabric of our lives for centuries.
It really has.
Yeah.
And now with this explosion of data and advancements in technology, the possibilities are even more exciting.
Yeah, for sure. Speaking of technology, I remember reading about those Cold War era spy satellites that would eject film canisters for retrieval by planes. It just seems crazy compared to how we collect data today.
It does, doesn't it? Figure 1.7 shows an illustration of that whole process, literally snatching these canisters out of midair to get their hands on that geospatial data.
Wow. Talk about dedication.
Right.
It was a different era, that's for sure. But even without the spy movie drama, there's been some incredible innovations in geospatial data acquisition.
Absolutely. The Landsat program, for example, has been capturing Earth imagery since 1972.
Wow, that's a long time.
It's provided invaluable data for monitoring deforestation, tracking urban growth, and even discovering new islands.
No way. Hold on. A whole island discovered thanks to satellite imagery?
Yes.
Which one?
Landsat Island, figure 1.8.
That's amazing.
It is. And today, we have even more sophisticated tools at our disposal. LiDAR uses lasers to create these incredibly detailed 3D maps of the Earth's surface. And OpenStreetMap, which relies on, like, a global community of volunteers.
Okay, cool. Crowdsourcing.
To create a constantly evolving map of the world.
It's incredible how far we've come. You know, we've gone from, like, film canisters and spy planes to lasers and crowdsourcing. And all of this data is, like, readily available now, just like a few clicks away.
Exactly. It's truly a golden age for geospatial analysis.
Okay, so we've talked about the history. We've talked about the data. But before we jump into Python, I think it'd be helpful to kind of get a handle on some key GIS concepts. Some of these terms always kind of throw me for a loop.
Okay, I hear it.
So, like, first up, thematic maps.
Right. So thematic maps, they're all about focusing on a specific theme or topic.
Okay.
So think about, like, a map showing population density or election results.
Yeah.
Or even something like the distribution of coffee shops in a city.
Okay, yeah.
And figure 1.12 shows a modern example from the U.S. Census Bureau with monthly business applications by state.
Got it. So it's not just about showing, like, roads and boundaries. It's about visualizing data related to a specific theme. Okay, what about projections? They always make my head spin.
Yeah, projections are tricky, but essential concept in GIS.
Yeah.
Essentially, they're mathematical formulas that we use to represent the Earth's curved surface on a flat map.
Right, because you can't just, like, flatten a sphere without some distortion, right?
Yeah.
I remember seeing those maps where, like, Greenland looks as big as Africa.
Exactly. That's a classic example of how projections can distort our perception of, like, size and distance.
Right.
Figure 5.6 shows the different UTM zones, which are a common system for dividing the Earth into manageable grids for mapping.
Okay, so, like, the choice of projection really matters depending on what you're trying to show.
Absolutely. If you're combining data from different sources, for example, you need to make sure the projections match up.
Okay.
Or you'll end up with misaligned data and inaccurate results.
That makes sense. What about spatial indexing?
Ooh, good one.
That sounds pretty intimidating.
Yeah, it might sound complex, but it's actually very practical. Imagine you have a massive data set with, like, millions of points.
Okay.
Spatial indexing helps you organize that data so that you can quickly find what you're looking for without having to search through every single point.
Okay, so it's like a super efficient search engine for spatial data.
Exactly. It's essential for working with large data sets because it just dramatically speeds up queries and makes spatial analysis much more efficient.
Okay. I'm starting to see how all these pieces fit together. We've got our historical context, our understanding of data acquisition, and now we've covered some key GIS concepts. I'm feeling, like, much more prepared to tackle Python.
Right.
So why is Python such a good fit for geospatial analysis?
Well, I think one of its greatest strengths is Python's flexibility. So it can handle a wide variety of geospatial data types. So shapefiles, GeoJSON, rasters, you name it, Python can probably work with it.
Okay, so it's like a universal language for geospatial data.
That's a great way to put it.
Okay, cool.
And then there's this incredible ecosystem of Python libraries that are specifically designed for geospatial tasks. So we're talking GDAL, PyShep, Fiona, Shapely.
Well, okay, that's a lot.
These libraries, they just provide a wealth of tools for reading, writing, manipulating, and analyzing geospatial data.
So it's like having, like, a whole toolkit filled with specialized instruments.
Exactly.
Oh,
And, you know, Python is remarkably beginner-friendly, too. The syntax is relatively simple and intuitive, so you can start writing, like, useful scripts, even with basic programming knowledge.
Okay, that's encouraging.
Yeah.
But can it handle, like, more advanced tasks as well?
Absolutely. So, you know, as you become more comfortable with Python, you can delve into more sophisticated techniques and even develop custom tools and workflows for your specific needs.
Okay, so Python is flexible, has a rich ecosystem of libraries, and caters to both beginners and experts. That's quite a combination. Now, let's talk about some of the cool projects in the book. Joel highlights some, like, really interesting applications of geospatial analysis with Python.
He does. There are so many to choose from.
Yeah. I'm looking at a table of contents here. Calculating satellite image cloud cover caught my eye. Sounds cool. But, like, how does that actually work?
It's pretty neat. It involves analyzing the spectral properties of the satellite image
Okay.
to identify and isolate cloud pixels from other land cover features.
So you're basically like teaching Python to see clouds.
You could say that.
Okay, that's cool.
And the applications are vast, from improving the accuracy of land cover classifications to monitoring weather patterns.
Right, okay. That one's definitely going on my to-learn list. What about geolocating photos? That's something everyone with a smartphone can relate to.
It is. It's a fascinating process.
Yeah.
By extracting metadata embedded in the photo, like GPS coordinates and timestamps, we can pinpoint the exact location where it was taken.
So you're basically creating a spatial connection to a personal memory.
Exactly. And beyond personal use, this technique has, valuable applications in fields like disaster response.
Okay.
Where geolocated photos from eyewitnesses can provide real-time information.
Wow, that's powerful stuff.
Yeah.
It's like turning everyday photos into data points for analysis.
Exactly.
Yeah.
And then there's a classic application that we all use every day, routing along streets.
Yeah.
And this project delves into the algorithms and techniques behind navigation apps like Google Maps.
Okay, so that's hitting close to home. I use those apps every day to navigate my city.
Right.
Wow. So this is just a glimpse into the world that Joel's book opens up.
Yeah.
We've seen how geospatial analysis has evolved from ancient cave paintings to sophisticated satellite imagery, and how Python is emerging as a powerful tool for tackling real-world problems.
And this is just the beginning. There's so much more to explore.
Yeah. All right, we'll be back in just a minute to continue our deep dive.
Welcome back. Last time we set the stage for geospatial analysis and why it's such a powerful combo with Python.
Yeah. Now let's roll up our sleeves and dive a bit deeper.
Okay, sounds good.
But I have to admit, one thing that always kind of intimidated me is just the sheer variety of geospatial data formats.
Right.
Shape files, GeoJSON, rasters, and it's where do you even start?
I hear you. It's like walking into a grocery store with a million different kinds of food. And you're just where do I even begin? But that's one of the things I really appreciate about this book. It breaks down this complex landscape in a really clear way.
Yeah. Instead of getting lost in the jargon, it helps you understand the key differences and why certain formats are better suited for certain tasks.
Exactly. And one of the fundamental distinctions is between vector data and raster data.
Right. We touched on this briefly before.
We did.
Vector data that's all about points, lines, polygons. It's kind of like drawing shapes on a map.
Precisely. So you use points to represent things like cities, landmarks, lines for roads, rivers, and then polygons for areas like countries, lakes. It's all about representing discrete objects.
Okay. And raster data, that's like a digital photograph, made up of pixels arranged in a grid.
Exactly. So think satellite imagery, aerial photos, even elevation models. They're all about representing those continuous surfaces.
Okay, so those are the two main categories. But even within those categories, there are a ton of different formats. Right?
That's right. And Joel provides a great overview of the most common ones, starting with vector formats.
Okay.
Shape files, for example, have been a staple in GIS for ages.
Yeah, I've definitely encountered those before. But they always seem to come as a bunch of files with different extensions. Why is that?
That's one of their quirks. A shapefile, it's not actually a single file. It's a collection of files that work together to store the spatial data, attributes, and projection information.
So it's like a team effort to represent those geographic features.
Okay.
What about GeoJSON?
Okay.
I've heard that's becoming more and more popular these days.
It is. GeoJSON is a more modern, web-friendly format based on JSON, a lightweight data interchange format.
I'm sensing a trend here. Lightweight and easy to use. Is that a common theme in geospatial data formats these days?
Absolutely. With the rise of web mapping and the need to share data seamlessly across platforms, there's a big push for interoperability and efficiency.
Makes sense. Are there any other vector formats that we should be aware of?
Definitely. GeoPackage is another one that's worth mentioning. It's an open, standards-based format. And it's designed to store a variety of geospatial data types all within a single file.
So it's like a one-stop shop for all your spatial data needs.
Exactly. Like having a spatial suitcase that can hold all your vector features, raster tiles, even attributes.
Okay. That's pretty handy. Now, what about the world of raster data?
Well, just like with vectors, there's a whole universe of raster formats out there. GeoTIFF is a popular choice. It's a versatile format. It can store georeferenced raster data, like satellite imagery.
So it's not just a pretty picture. It also knows where it is on Earth.
Exactly. That's what makes it so powerful for analysis. You can combine it with other data layers and perform special operations.
Got it. So GeoTIFF, one to remember. Any others?
Well, there's ASCII grid, which is a simple, human-readable format often used for elevation data.
ASCII grid. That sounds familiar. Didn't we use that in one of the projects we talked about earlier?
We did. It's a great format for learning and experimenting because you can actually open the file in a text editor and see the raw data values.
Oh, that's interesting. It helps you understand the structure of raster data in like a very direct way. Okay, so we got GeoTIFF, ASCII grid. Anything else?
There are also specialized formats like LiDAR, which stores point cloud data captured by lasers.
Ah, yes. Those incredibly detailed point clouds that we were talking about earlier. And then there are like web-based formats, right?
You got it. Formats like WMTS or WMS, they allow us to access raster tiles on demand.
Okay.
So instead of downloading like a massive data set, you can just stream the tiles you need for a specific area.
That's a game changer for web mapping, right? It just makes things so much faster and more efficient.
Exactly. So as you can see, the world of geospatial data formats, it's vast.
Yeah.
It's varied. But the good news is Python provides libraries that can handle this incredible diversity.
That's a relief. I wouldn't want to learn like a separate language for each data format. So how do these Python libraries come into play?
Well, before we jump into specific libraries for different formats, there's a kind of a foundational library that underpins a lot of geospatial work in Python. It's called GDAL.
GDAL. I think I've seen that mentioned a few times in the book.
Yeah, it's a real workhorse. GDAL stands for Geospatial Data Abstraction Library, and it provides a common interface for accessing and manipulating a wide range of geospatial data formats.
So it's like the universal translator for geospatial data in Python.
That's a great analogy. It acts as a bridge between different formats, allowing you to work with them seamlessly.
That's incredibly useful. It sounds like GDAL is a must-have for anyone working with geospatial data in Python.
Absolutely is. And the best part is it's incredibly powerful and versatile.
Yeah.
It can handle everything from reading and writing data to performing complex geoprocessing operations.
Okay. So GDAL is at the top of my list. But what about libraries for specific data formats?
Well, if you're working with shapefiles, PyShap is a classic choice.
Yeah.
It's a pure Python library, which often means it's easier to install and use, and it just makes working with shapefiles a breeze.
PyShap for shapefiles. Got it. What about raster data?
For raster data, you can't go wrong with Rasterio. It's a Pythonic and efficient library for reading and writing a wide range of raster formats, including GeoTIFF.
Rasterio for rasters. Makes sense. And it's built on top of GDL, right?
That's right. So you still get all the power and flexibility of GDL, but with a more user-friendly interface that's specifically designed for working with rasters.
Okay. I'm starting to like build a mental map of this geospatial Python landscape. We have GDL as the foundation.
Right.
Then specialized libraries like PySpic for shapefiles, Rasterio for rasters. What about web-based formats? Are there libraries for those as well?
Absolutely. For working with web services like WMS and WFS, you might consider libraries like OWSLib.
Okay. So we can use Python to like request data from those web services.
Right.
And like integrate it into our analysis.
Exactly. It's like opening a portal to this vast world of geospatial data that's constantly being updated and refined.
This is amazing. We've gone from like a jungle of data formats to a well-equipped toolkit for accessing and manipulating them in Python.
It's empowering, isn't it? With these tools, we can move beyond simply understanding the data to actually doing something with it.
That's what I'm really excited about. You know, we've talked about accessing and managing the data. But what about the actual analysis? Like, what kind of spatial analysis can we do with Python?
That's where things get really interesting. Spatial analysis is like the heart of geospatial work. It's where we transform data into insights and knowledge. And Python provides a wealth of tools for doing just that.
Okay. I'm all ears. What kind of spatial analysis can we do in Python?
We can do everything, from simple geometric calculations to complex spatial modeling. For example, let's say you want to calculate the distance between 2 points.
Okay, like the distance between two cities on a map.
Exactly. Python libraries, like Shapely, have functions for doing just that. You can calculate that distance with a few lines of code.
That seems pretty straightforward. What about something a bit more complex?
Well, we can perform spatial queries to select features based on their location or attributes. So imagine you want to find all the houses within a certain radius of a school.
Oh, okay. Or all the coffee shops that fall within a specific neighborhood boundary.
Exactly. Those are all examples of spatial queries that you can easily perform in Python. And then there are spatial overlays,
Okay.
which allow you to combine data from different layers.
So you're not just looking at each layer in isolation, you're like integrating them spatially.
That's right. For instance, you could overlay a layer of soil types with a layer of land use to identify areas suitable for agriculture.
I see. That makes a lot of sense. Are there other types of analysis we can do?
Absolutely. There's network analysis, which is all about modeling and analyzing things like transportation networks or utility grids.
So we could like find the shortest route between 2 points, taking into account traffic conditions.
Right.
Or maybe identify the optimal location for a new fire station.
Exactly. Those are classic examples of network analysis problems that you can solve using Python. As you can see, the possibilities for spatial analysis in Python are vast.
Yeah, my head is spinning with all the possibilities.
Yeah.
This is really exciting. We've learned so much already. You know, we've explored the diverse world of geospatial data formats, the foundational power of GDAL and other Python libraries, and now we've even delved into the exciting realm of spatial analysis.
And we're not done yet. There's more.
Oh, yes. There's a whole universe of more specialized and exciting applications waiting to be explored.
Okay, I'm officially on the edge of my seat. Bring on part 3. Okay, we're back. For the final part of our deep dive into learning geospatial analysis with Python, you know, I'm ready to hear about these specialized applications you teased at the end of part 2.
Well, one area that's particularly fascinating is working with elevation data.
Okay.
You see, the Earth's surface, it's not a flat plane.
Right.
It's a dynamic landscape, you know, mountains, valleys, everything in between.
Right. And I'm already picturing those like cool 3D visualizations of like mountain ranges. But is there more to it than just making pretty pictures? Oh, absolutely. Python gives us the tools to analyze elevation data and extract, you know, all sorts of valuable insights. One way we can represent elevation data is using digital elevation models, or DEMs.
DEMs. Okay, yeah, that rings a bell. Aren't those raster data sets where each pixel represents an elevation value?
That's right. Think of it like a grid draped over the Earth's surface, where each cell contains a measurement of how high that point is. And with Python, we can read these DEMs, manipulate them, really unlock their potential.
Okay, I'm intrigued. What kind of insights can we get from DEMs?
For example, we can calculate the slope of the terrain.
Okay.
This tells us like how steep the terrain is at any given point.
So that would be useful for like hiking or skiing, right? Like knowing how challenging the terrain is.
Exactly. But it goes beyond recreational uses. You know, slope is crucial for environmental modeling because it influences things like water runoff, soil erosion, even the distribution of plant and animal species.
Wow, I hadn't thought about those implications. So like analyzing slope can tell us like a lot about the environment. What other insights can we get from elevation data?
We can also calculate aspect, which tells us which direction the slope is facing.
Okay.
This is important for understanding things like solar radiation exposure.
So a south-facing slope would get more sunlight than a north-facing slope,
right?
Which could, you know, impact things like microclimates and vegetation patterns.
Exactly. And we can go beyond just calculations. You know, Python makes it easy to create stunning 3D visualizations of the terrain using techniques like hill shading.
Oh, yeah. Those are the visualizations that make the terrain look like so realistic, right?
Right.
Almost like a 3D topographic map.
Exactly. Python libraries like Matplotlib make it really easy to create those hillshade visualizations.
Okay. This is really cool stuff. Are there any other techniques for visualizing elevation data?
Well, we can also create contour lines from DEMs.
Okay.
Those are the lines on topographic maps that connect points of equal elevation.
Oh, yeah. I remember those from geography class.
Right.
They're great for visualizing the shape of the terrain and identifying features like ridges and valleys.
They are. And Python libraries like GDAL have algorithms for generating those contour lines from DEMs.
Okay, so we can analyze slope, aspect, create hillshades, generate contour lines. What about LiDAR data? We talked about those complex point clouds earlier. Can Python handle that kind of data as well?
LiDAR data is on another level of detail.
Yeah.
But Python is definitely up to the challenge.
Okay, good.
We can use libraries like PDL to read, process, and visualize LiDAR data.
So what sorts of things can we do with LiDAR in Python?
We can create incredibly detailed 3D models of the Earth's surface.
Okay.
Identify individual trees in a forest, or even model things like the spread of flooding.
Wow, that's impressive. It sounds like LiDAR opens up like a whole new world of possibilities for geospatial analysis.
It definitely does. And as LiDAR data becomes more readily available, Python will be an essential tool for unlocking its full potential.
Okay, so we've talked about elevation data, LiDAR. What other specialized applications should we explore?
Well, there's a whole field dedicated to working with real-time geospatial data.
Oh, wow.
So think like tracking moving objects, monitoring sensor networks, even analyzing social media feeds for location-based insights.
That's what I call real-time geospatial analysis, like those maps showing live traffic updates or the location of delivery trucks.
Exactly. And Python provides the tools to not only visualize, but also analyze this data as it's streaming in.
Okay.
Libraries like GeoPandas make it possible to work with time-stamped geospatial data and create those dynamic visualizations you were talking about.
So you can watch how spatial patterns change over time.
Right.
Like movement of people during rush hour or the spread of a wildfire.
Exactly. With the rise of the Internet of Things, this kind of real-time geospatial analysis is becoming increasingly important in all sorts of fields.
This has been an incredible journey. It feels like the applications for geospatial analysis with Python are truly limitless.
I agree. And Python will continue to be a key player as the field evolves and new applications emerge.
Well, I have to say, this deep dive has been truly eye-opening. We've covered so much ground, the history of geospatial analysis, the power of Python libraries like GDAL, the fundamentals of spatial analysis, and now all these amazing specialized applications. I'm feeling inspired to dive in and start exploring.
That's fantastic. And don't forget about Joel Lawhead's book, Learning Geospatial Analysis with Python. It's an excellent resource for anyone who wants to learn more.
Yeah, it definitely is. And as always, we'd love to hear from you. What geospatial challenges are you tackling with Python?
Right.
Let us know in the comments.
Until next time, keep exploring, keep analyzing, and keep pushing the boundaries of what's possible with geospatial analysis.
And remember, the world is your geospatial oyster. Happy mapping, everyone.